A while ago, I posted this blog post about a motorcycle tire study. Essentially, I had always had difficulty creating a motorcycle tire that would work at different details. This has a lot to do with the sort of curvature of a motorcycle tire. It curves on multiple planes at the same time, and then it's got the tread that's sort of grooved into it. And I finally figured out a way to get a really good looking detailed motorcycle tire tread that can be sort of subdivided. You can use a hyperNURBS or a smooth mesh modifier on it, and it'll actually allow you to change the subdivision level of the motorcycle tire even after you've created the model. At first, this doesn't sound like that big of a challenge, but when you actually get down to it and try to create one, you'll see how the traditional modeling techniques sort of just fall apart. Here's a profile, a spline. This is typically how I start modeling a motorcycle tire. You have your profile, and just for illustrative purposes, you sort of bring it along, sweep it all around 360 degrees, and at the end of it you have sort of a tire shape. Once you've got this, you can increase the detail, reduce the detail as much as you want, and normally that's good enough. If you're going to texture map the tire, that's going to work just fine. You just put a normal map or a bump map on there for the treads, and that's it. However, if you're going to model the actual grooves in the tire, it becomes a little bit more challenging. The reason is, if you try to cut into this model using a Boolean operator or something else like that, you're going to get a lot of messy geometry. So one of the ways that a lot of folks do it is to create one segment of the tire and then just copy it around in a circle. And that works up to a certain point. Here I have a really complicated hierarchy of how I created that tire that I just showed you. So I started off with this path that sort of defined the tread pattern. I'm just trying to find my geometry. Let's hide some of this stuff. So I had this path. Well, that's still really messy. Let's see. Okay. So I had this path that was my tire tread, and that was to be my reference material. And I use this to sort of create the geometry you see here. I'm just going to turn the hyperNURBS off. And so right here we have a section of tire, sort of square on the edges. Almost looks more like a car tire because it's so square. And this works really well to create the geometry and copy it along a straight line. So I have a bunch of instances here that extend this tire geometry into the distance. Typically, the next step would be to use bend modifiers to wrap it around like that. And this is typically where a car tire tutorial would end. Now at this point, it gets kind of interesting because on a motorcycle tire, you have to bend the left and right sides as well. So to make the point a little clearer, I'm going to show these bend modifiers, the deformers rather. So I have two bend deformers that will arc the tire and another one that will wrap it around 360 degrees. So if I turn these on, you can see I'm bending one side of the tire, and then I'm bending the other side, and then I'm going to wrap it around in a circle. This is the point where most motorcycle tire modeling stops. Got some extra stuff here. I'm just going to switch it up a little bit. So most of the time you just have this hierarchy where, oh, I messed that up. Undo, undo. Okay. So most of the time you just have this hierarchy where you have a bend, a couple different bends, and it looks like we have success. Yay. I've successfully modeled a motorcycle tire that looks really smooth, it looks really nice, but the resolution won't increase at all. So, for instance, if I wanted to subdivide this tire, that's where it gets a little bit tricky. So typically, you would basically say, okay, well let's take this object and let's just subdivide it. No big deal. But something strange happens. Here you can see the subdivision is actually, it doesn't quite look right. Like you're seeing, it's difficult to see. It gets a little bit more pronounced as you get further along the process. But what we're actually seeing here is some pinching and some strange effects. If you turn the subdivision up, sometimes it becomes more pronounced, where you're sort of seeing these lumps. Essentially, we're subdividing faceted geometry. Now, as I warned before, this is a really strange issue, because at a distance you don't see it. It looks okay. But when you really get in, you can see that things just don't quite look right. It's almost like you have flat spots on something that should otherwise be perfectly smooth and curved. And the longer you stare at it, the lumpier it looks. And this is because what we're doing is we're taking completed geometry that looks fine if it's not subdivided. It looks pretty good like this. And we're subdividing it. And so what tends to happen is these faces are subdivided as they lie, as they sort of exist there. So these faces are a little bit bigger than the adjacent faces. The geometry isn't perfect. It is all quads, but it's still not perfect geometry. And what ends up happening is you flatten out the flat spots even more by using the hypernerbs on it. So after a little bit of banging my head against this problem, I realized that the trick is actually to do the deformation last. So here's how that works. We put this entire structure inside of the hypernerbs and it didn't really look that great. I'm just going to hide the deformers so we can see what's going on. Didn't really look that great. However, the fix is really, really simple. You take the hypernerbs and you actually place it below the deformers. So for instance, I'm going to place it right here, and then we put this object inside of the hypernerbs. What we're in essence doing is we're subdividing this object, then bending it. So if we turn our hypernerbs on, you can see proof of what I just proclaimed. We are actually subdividing this object first. So this object is now nice and smooth. And then we're bending it. Now let's play with the bends once we do them to make the point. So immediately you can see this is a much, much better result. It looks perfectly smooth. Every curve is correct. You don't get any pinching or flat spots near the tips of these or near the edges. It's basically smooth and curved any angle you look at it. And that's what a motorcycle, at least a sport motorcycle tire looks like. So that really sells the effect, but now let's look at why. What we've done is we've taken this flat object and we've subdivided it, which means that there's no bias. There's no instance where, oh, you know, because this was a larger polygon originally than its neighbor, so it got subdivided at a different angle. Everything is being subdivided like an equal, on the same plane. Everything is flat, everything is square, it's all predictable, and it's all smooth. If I turn the wireframe off, it's perfectly smooth. And then at that point, we're going to bring a bend in. So first we bend that side. And because we're bending geometry that's already been subdivided, there's a lot more geometry to bend. So here you can see the geometry very smoothly bending. And if I reduce the hyperNURBS level, you can see the geometry is still smoothly bending. There's just less geometry. So in essence, what we're doing is preserving the bent shape, but we're constructing the object in a way where it doesn't actually care how much geometry is in it. It's just trying to attain a final shape. And like I said before, that's happening because we're doing the deformation last. What we're actually looking at when we turn all these deformers on is a straight strip of tire, subdivided, that we're then bending. So I really hope that you enjoyed this screencast. It's just me looking at one of the ways that I overcame one of these issues I was having while modeling a motorcycle tire. And I really hope it was useful to some of you guys. You can see just how perfectly smooth it is there. And yeah, let me know what you think in the comments, or you know, just I'd love to know what you think of the video. So thanks for watching, and until next time.